In this video, we're going to discuss factor theorem and show some examples and problems related to factor theorem. So basically, a factor theorem states that it's just actually an extension of a remainder theorem. So let's go back to the idea of remainder theorem. Remainder theorem tells us that if we have a polynomial p of x, if we were going to divide this by a linear divisor, which is x minus t, we're going to have a remainder. That's why it's called remainder theorem, because it has at the same time the remainder. Our remainder will just be evaluating the polynomial at x equals c. Okay, at x equals c. So extending that, so factor theorem tells us that if we have p of x, any polynomial, algebraic polynomial, um, divided by a linear divisor, x minus c, we'll get a remainder. Okay, we'll get a remainder. Okay, of course, the same thing, just an extension of remainder theorem, evaluating the polynomial at x equals c, and the result, the remainder will become 0. So that is basically the idea of, basically, when the remainder is 0, therefore the divisor is actually a factor of the dividend. So that's the idea. So for example, if you are going to divide 8 divided by 4, then we have 2, then 8, then we have 0. So since the remainder is 0, therefore you can say that 4 is a factor of 8. So that's basically the idea here. We're just bringing it into a algebraic polynomial. Okay, so that's it. So let's try some problems. So but basically, let's try first recall what is the idea of factors. Okay, so let's say a polynomial expressed as factors. You're simply rewriting a polynomial in terms of the product of its factors. So let us say, if we're going to say 8, you can say that as 4 times 2. If you have a polynomial x squared plus 6x plus 5, we can express this as x plus 1 times x plus 5. So this basically, x plus 1 is a factor of this polynomial, and at the same time x plus 5 is a factor of this polynomial. So that's basically the idea of factor theorem. It tells us if a divisor, a linear divisor, is either a factor of a polynomial or not. Okay, so let's have some examples here. We have number 1, determine if x plus 2 is if x plus 2 is a factor of whether x plus 2, let's change that, whether x plus 2 is a factor of x cubed plus 2x squared minus 1. So it's number 1. We have our solution. So again, if we're going to using the remainder theorem, this becomes x equals negative 2. So we have p of negative 2 must be 0. Let us say this is our p of x. Okay, so p of negative 2 must be 0 in order for this to be a factor of this one. Okay, so let's try that one. Then we have p of negative 2 equals negative 2 cubed minus 2 times negative 2 squared minus 1 equals, this is negative 8, negative 8 minus 1. So basically this is not 0. Okay, this is not 0, this is negative 17. Since the result, the remainder is negative 17 and not 0. Okay, so p of 2 is negative 17 and not 0. Therefore, we can say that, therefore, x plus 2 is not a factor of p of x. What is our p of x? This one. Okay. So that is basically that one. So number 2, we have here, determine if whether 2x minus 1 is a factor of 2x cubed minus 3x squared minus 2x. So let's try that one. So we're trying to, what we are trying to look at is that if, so let us say this is f of x. This polynomial is f of x. This one. So you're trying to see, okay, we are trying to see if f of negative 2 is 0. Is that it? Is f of negative 2 equals to 0? If 0 is the result, therefore 2x minus 1 is a factor. So let's continue. We have 2 times negative 2 cubed. Oh, no. You're not. It should be not negative 2, but we are using this one as our factor. Therefore, that is 2x minus 1. Therefore, x is 1 half. Okay. So we are trying to see if f of 1 half is 0. Okay. So let's substitute that 1 half to our polynomial. We have 2 times 1 half cubed minus 3 times 1 half square minus 2 times 1 half. So we have 2 times 1 half raised to 3 is 1/8 minus 3 1 half raised to 2 is 1/4. Then twice of 1 half is actually 1. Then we'll have 1/4 minus 3/4 minus 1. Let's recall 2x, oh, that should be plus there. 2x 1/4 plus 3/4 is 1. This becomes 1 minus 1. Oh, this becomes 0. So since the remainder is 0, we can say that this one, this 2x minus 1 is a factor of this. Okay, 2x minus 1 is a factor of this. So we have, therefore 2x minus 1 is a factor of, what's that? 2x cubed plus 3x squared minus 2x. Okay, which is the f of x. Okay, so what does it tell us is that if we're going to express, if there are 3 factors of this polynomial, I'm just extending the concept. If we're going to let us say we can completely factor this one into 3 factors, since that is cube. Let us say like that. Okay, one of them is 2x minus 1, and there's still more. Okay, so next problem is we have number 3. So if x minus 1 is a factor of this polynomial, 2x squared minus 2kx plus 1, solve for the value of k. So it's simply asking us to look for the value of k such that the result will become x plus 1 becomes a factor of this. So what must be the k so that this one becomes a factor of that? So again, using factor theorem, since it's just a reverse of the first and second problem. Let us say this is our p of x. P of x must be 0. Or since that is x equals 1, you can say that P of 1 must be 0. Okay, that must be 0. So that this becomes a factor. Okay, so we can say that this must be 0. Okay, and let's try to substitute 1 in the equation of polynomial. 2k times 1 plus 1. It simply tells us that we have this one becomes 2. Okay, then this becomes 1, then we have negative 3 equals, this will becomes negative 2k. So k is simply 3 over 2. So this k here must be replaced with 3 over 2 so that the resulting polynomial with 3 over 2 as the value of k, the resulting polynomial is now factorable with this factor. Okay, it's now divisible. The other term is divisible with this factor. Okay, so we're just setting it into 0 because there is already an established statement that this must be a factor. Okay, this must be a factor, therefore we're setting it into 0 already. Okay, in the first and second problem, we're just determining if it's a factor. Okay, in the third problem, we are already establishing that it must be a factor. That's why we will set this into 0. The remainder must be 0 so that it will become a factor. And because of that, we're doing the same and look for the value of k. Okay. So problem 4 is just like the same with number 3. However, it involves two variables. Again, the strategy if you're looking for two variables is that we are going to form two equations involving those two unknowns. So here we have if x squared minus 3x plus 2 is a factor of 2x raised to 4 plus px cubed plus x squared plus qx minus 12. Find the value of p and of the value of q. So what we're going to do is, as you can see here, our divisor is a quadratic polynomial. So let's factor this one. We can say that x squared minus 3x plus 2 is equals to this becomes x minus 2 and x minus 1. Okay, so we are going to form, so if this whole thing is a factor of that, therefore it's the factors of this one. Okay, this one is also factor of that one. Okay, so it's like saying that if 4 is a factor of 8, therefore the factors of 4 are also factors of 8. It's like, what are the factors of 4? 2 and 2. Okay. So that the same with that idea. So what we're going to do is, how can we form two separate equations involving p and q with this given? So first equation, we are going to use x minus 2. Okay, so let's say form an equation using x minus 2. So the same idea, p, this becomes x equals to p of 2 must be 0. Okay, so p of 2 must be 0. So that's number 1. Okay, so we can have now 0 equals 2, substitute this 2 in that one, so we have then we have 2 square plus 2q minus 12. Okay, so so we have now we have now 2 raised to 4 is 16 times 2 is 32. Other thing, we can simplify this into 2 raised to 5. And we have 2 cubed means 8p. Then we have another 4. Then we have another 2q and 12. Okay. We can move the constants on the left side. We may not also move them. It's up to you. So we have here 36 minus 12 becomes 24. So if we're going to move that there, that's negative 24. Then I have 8p plus 2q. Simplifying this further will give us negative 12 4p plus q. So this is our first equation. This is our first equation. Okay. So our second equation is that we're going to form an equation using the second factor of our divisor. Okay. So the first factor of our divisor is x minus 2. We just formed that one this here. And the second factor is x minus 1 because this one is also a factor of that. So we will form an equation using x minus 1. Using x minus 1. Okay, so we say that since this one is a factor, we say that p of negative 1 is just 0. Okay. It's just 0, no, positive 1. P of 1 is just 0. So we can continue. We have 0 equals 2 times 1 raised to 4 plus p times 1 raised to 3 plus 1 square plus q minus 12. So we have 0 equals 2 plus p plus 1 plus q minus 12, and we have 2 plus 1 is 3, 3 minus 12 is negative 9. Therefore, we have positive 9 equals p plus q. So this is our second equation. Okay. So we are going to solve the two equations simultaneously using elimination or substitution. But looking at q and q, we can eliminate it directly. So we have negative 12. So by elimination, we have negative 12 equals 4p plus q. We have 9 equals p plus q. Then we have, subtracting these two equations, we have negative 21. I think that's negative 21. And we have negative 4p minus p is just 3p, and q minus q is just 0. Therefore, p must be negative 7. Oh, p must be negative 7, so that our divisor on top a while ago is a factor of our p of x. So let's look for our value of q. So we know that 9 is just p plus q. So if we have 9, which is our p is negative 7, therefore our q is just, this is 9. Okay. So our q is just 16. Yeah, 16. P is negative 7 and q is just positive 16. So we're just getting it there. Okay, so p equals negative 7 and q must be positive 16, so that when we plug in those values of p and q there, this becomes a factor of that. Okay, this becomes a factor of that. Meaning, if you're going to, this one, if you're going to express it as, let us say this is this can be factorable into 4 separate factors, because this is 2x raised to 4. Let us say you can separate that one into like that. Not sure, maybe there are only 3, but we are already sure that we know the 2 factors. So two of them is x minus 2 and x minus 1, and we do not know yet this one. Okay, so that is the application of factor theorem.